Hello, hello. There we go. Testing 1, 2. Yes, we are live. Close that. What's going on? Make sure my phone's on silent. So, too high. As you can see, we are rocking a new do. So we're gonna wait for everyone to get in here. Oh, what a day. What's going on with you? Oh, nice. That sounds like lots of fun. I'm enjoying doing these little sessions for an hour and a half at least. It does makes me feel good. So, audio sound good on your end? That's good. Yeah, it's definitely needed out there because there's a lot of places that are lacking training. And I, taught for 16 years and I thoroughly enjoy this. I'll be going back to teaching this fall part time again with a new program. So I look forward to bringing my knowledge to those students as well in this national program. But I went out and picked up some new stuff today. Picked up the new Honeywell Focus Pros. So This is new. They have several different styles out there. That's what it looks like. Battery connections. Your Yeah, that's what I said. They just came out. Thermostat connections. And here's the cool thing. There's the back plate for it. So yeah, I thought this was like, you know, that can mount on there. You like the T6? Looky. So I went out and spent about $200 more today for all this training stuff. Between the board and what I got today, I got $600 into this. So yeah, but comes with the installation guide. What I like is it gives you the old school paperwork. That does your program set points like the old 8000s did, which I think is pretty cool. I, I got a lot of stuff secondhand, and I just like to have new stuff that I know works for playing with this stuff when I create control boards. So it's just how I do things. I mean, that's what we did at school. I would always have a bunch of stuff at school for everything. So yeah. So today's topic. Not that. Yeah, that's what I wanted. Here it is. Basic circuits. So we talked thermostats last week, but we're talking about basic circuits this week. And part of our basic circuits is going to be thermostats and setting them up as well as part of everything else. So, with that being said, let's start off with two favorites. Everyone, welcome to training today. We have a low pressure switch and a high pressure switch. We can tell they're different because they're still in the bags. But we take them out of the bags without looking at the numbers, they look exactly the same. Now, if you look right here, I don't know how well if it'll focus or not. Probably not. So it opens at 25 psi plus or minus 7 and closes at 50 plus or minus 7. This is our high pressure. This opens at 600 plus or minus 25 and closes at 475 plus or minus 25. Now, if I didn't know these labels were on here, I had two identicals. I'm just going to flip them around and kind of hold so you can't see. And I'm going to pull this cap out because that will definitely make them different. Show you. I've got two pressure switches, and I'm not sure which one's which. But I know I had them on the truck, and let's say they've got, yes, 25 psi, not percent. And I'm not sure which one is which. Okay. So I didn't bring a meter with me because just don't need one today, but we'll definitely need one for next on the 8th, which is going to be the fun class. If I put my meter leads on this two right here, and I get continuity, and I put my leads on this two, I get no continuity. The no continuity is going to be your low pressure switch because it's open. There's no pressure pushing the switch to close it. Continuity on these two leads will be your high pressure switch because there's no pressure opening the switch. So your high pressure switches out of the bag will always be closed. Your low pressure switches out of the bag will always be open. Now, like I said, I'm covering so I can't see which one's which. So this is my low pressure. This is my high pressure. You can't tell because the numbers are hot hidden. But if you can't read the numbers on here, if something happens and you know you have a 410A high pressure, low pressure switches, you're not sure which one it was. That is one way you can figure out. These will be going on the board, and I will be putting swivel T's on here with some pressure on them just so you can kind of see them open and close. It's gonna be fun getting that 600 one to pressurize in that little bit. But yeah, I'm gonna put a swivel T on there to do that. Opener. So this one is normally open. The low pressure is normally open. High pressure is normally closed. Once pressure is applied, low pressure closes. Exceeding pressure on the high pressure, it opens. Now, I know we talked thermostats last week and some controls, but I picked up 3 identical thermostats. Okay. And I'm going to stack them all right here for you so you can see them all at once. The backs look exactly the same, and so do the fronts. All right. 3 identical thermostats. They all have Y, G, R, O across the top. The bottom you have E and C, and on the left side you have W2. Now the bottom one has a little few extra controls. It has an L, an X, a Y, and a B. So let's look at these two first. See, the top one says Nordine, the bottom says Genitol. Exact same thermostat. Yeah, I'm gonna do that in a little bit here with the board, so you can see. But you can see right here, exact same thermostat, 2 different manufacturers, same wiring. Now the third one, as you can see, is a Rude Ream thermostat. It has the L, the X, and an OB. But let's compare it to one of the other ones. Notice there's no common on the top thermostat. The common is the X. That is common on these older type thermostats sometimes. So if you have one that has an X and you don't see a common, X is your common. I just thought this was neat to have since they had them there at the store in the bin to pull out and show. Then I picked up some base plates. Different same looking base plate, same number of holes and everything, but as you will see, Here's the top one. Here's the first one. YOHXRGWB and T. Okay. Here's your other one. YL. See if we focus in again. It's not going to focus. So it's got YLXRGEW2, BO, and W3. And both of these are heat pump thermostats, sub bases. So let's try this again. Let's see if it'll. There you go. So again, no common, but X is there for common. And you can see the burn or the heat wear on the tabs here that go on that part there. Same with this one here. X again is common. So these old sub bases, the front cover would sit and that had little metal prongs that attach this, which would communicate back and forth between the two. And rotate this real quick. Low pressure, high pressure. You can see the gap where this is open. You can see how this is closed. Now, if you notice, the contact point is below, and this one is up. So when this trips, it'll go above. And when this makes, it'll go to the contact point. Okay. So that is your control there. So you get your low pressure, your high pressure. Now, part of your controls is your brain of the operation, the thermostats. It controls everything about it. So the next part we're going to get into is some fun things. And some of this training overlaps with other trainings modules, so it's good to repeat everything. On your sequencers, and this is a sequencer, as you can see. Low voltage on the bottom, high voltage on top. This is what's known as a single stack because there's only one stack. You have double stacks, so it would have two of these on top of it. One on top of that. You have a triple stack, would be a third one. Always going to have low voltage here, and single, double, or triple stack. I have a double stack on the board, which I'll show you. You have these numbers right here on top of your sequencers, okay? And it's kind of hard to see, which you're not going to be able to see on this. You can hardly see on that. But they're not the exact numbers on here, but we're going to use these numbers for many reasons. So when 24 volts is applied to your bottom, okay, when this gets energized, inside of here is a bimetal disc and a pin. When that pin heats up, the disc heats up, it pushes a pin, which in turn makes this have contact. Okay. Little porcelain pin, boom, makes contact. This porcelain's not entered, doesn't create electricity. So when it does that, it has to heat up for a certain time. So H stands for the heat up, how long it takes that bimetal disc to heat up. It could take 60 to 90 seconds. It could take, this one here on here says 40 to 110. So the one I have here is 40 to 110 seconds on here it says 1 to 20 to cool down. So it could take 40 to almost 2 minutes for this to click on. All right. It takes less time for it to cool down. And of course, they have M1, M2 on either side of it. Now, when you're messing with sequencers, you can buy aftermarkets, you can buy factories. If you don't have, if you have to get an aftermarket, try to find one that's as close to the numbers as possible. Is my best bet. Is my best recommendation. Um, you don't want to say, okay, well, the old heat up one was 30 to 90. Let me put one that's going to take longer or shorter. You want to get the closest to you can get. So 40 to 110, 60 to 90, it's close. 1 to 20, 1 to 30, they're close. So you can always find something that will match closely to this, to a factory one with some aftermarket sequencers. Okay. So SPST, SPDT, DPST, DPDT. These all stand for single pole, single throw, double pole, double throw, double throw, double pole, single throw, single pole, double throw. You get 4 different variations with this. Okay. So if I drew out this mark right here, this is a standard 9340, 9341, 9342 relay wiring schematic. Okay. And how it operates. So you have your 24 common if it's a one, if it's a, so this is 9340, which is 24, 341, 120, 342, 240. Okay. So, with that being said, depends on your relay, depends on your coil voltage. I have a 120 over there, which I showed last week, but we'll go over it still because it's all part of the controls and everything else we have to deal with. So, these acronyms apply to this. Now, there are other relays that have different numbers that look the same, where you can get 1 to 2 is normally open, 4 to 5 is normally open, 4 to 6 is normally closed, and 1 to 3 is normally closed. When power gets energized, 1 to 2 get closed, 4 to 5 get closed, 1 to 3 opens, and 4 to 6 open. Okay. So knowing that in your schematic, everything is drawn de energized. means no power has been applied to the circuit. So that's what we have here. Now, if I were to take this out, I'm going to leave the stuff up there. And I'm going to draw one more for you that's going to throw you off for a second. So 24 common, 24 common, 24 common on each side of it. And if you're kind of figuring out where we're going with this, contactors. So L1, L2, L1, L2. This is what everyone sees in the field for us. Single pole, double pole. Okay. Single pole, double pole. So we're focusing on this top part here, single pole and double pole. Now this is a single pole, and it's got one point of contact, so it would say single throw. Double pole, 2 points of contact, double throw. We're energizing 2 points. Energizing 1 point. Even though your compressor, your fan come off of it, you're still throwing that deal circuit. Now this here, 1, 2, 3. So you have L1, L2, L3. Triple pole, triple throw. This is more of your commercial or three-phase systems. So you'll have compressor, compressor, compressor lines coming in. If your blower motor, your blower motor may have its own contactor with its 3 lines. Your condenser fan motor may be on a double pole contactor. Depends on the type of system you're messing with. It depends on how the manufacturer's wired it up and what controls they're using. I know a lot of package units that will use 3-pole contactors. Also know they'll use double pole. Carrier is notorious for putting a double pole contactor and a single pole contactor in their systems and not use a 3-pole contactor. So with knowing which contactors you're using, make sure you put the right ones in. Now, if you go residential wise, some of your single poles will be either 30 amp or 40 amp. Some of these will be either 30 or 40, and some of them can be 60 as well. So knowing your amperage on your contactor is important because you don't want to put a 30 amp contactor on something that could have up to 60 amps. So a double pole for a 2.5 ton unit that only does say 40 amps, where a 5 ton that requires a 60 amp fuse because it can pull more amperage might require a 60 amp contactor, double pole. You just got to look at those numbers and read and make sure you do that. Now, everyone out there in the industry, we all stock parts, just numerous. And we try to stock the higher of the two. So that way you make sure that you're always covered on everything you do. So I'm going to take this out. All right, sorry about that. So, basic circuits. Transformer. Now, there's one small thing people forget about on transformers, okay? She'll focus in a second here. Mm, Reposition, see if she'll autofocus in. Of course not. Let me try drawing it bigger, see if she'll focus on that better. Of course, camera wants to be stupid today. So I'm gonna draw a little bit bigger here so everyone can see. There we go. So on transformers, if you're messing with a commercial unit, you will have a tap here that is right beside the 230 tap that says 208. If your line voltage coming in is 208, you need to move your wire from here to here. Reason being, on 208 volts to 24, you're going to get 20 to 22 volts, right? On 230, if we're still wired on the 230 tap, 24 to 27 volts roughly. Depends. Sometimes it's 26, but we'll just go with the 27. If I don't move this 208 wire over to the 208 tap, I'm going to be getting this voltage right here. It can cause contactors and relays to overexert themselves to try to get the 24 volts to close those coils and make them work properly. So you really need to make sure you're wiring your high voltage on those commercial package units to the 208 circuit if it's 208. Okay. Now, sometimes with three phase, you'll have different circuits coming into it, different voltages. But for main thing, you want to make sure that this is correct. And I'm gonna get to this wiring in here with the high voltage here to explain that to you. So make sure if you're using 208 volt, your tap is on 208. Because if not, if your tap is here on 208 volts, you'll get this low voltage. As soon as you move the tap over here to 208, you'll get your 24 to 27 volts. Okay. This is crucial because everything being so electricity sensitive now, this will throw off your system and cause you to to mess up contactors and relays. All right. So let's say we have a 240 volt three-phase system. Incoming voltage from each leg to ground, 120, 120, 120. So if I go from here to here, 240. If I go from here to here, 240. If I go from here to here, 240, right? Let's say it was a 208 system. I would still get the one, I would get one, I'd get 208, 208, 208. Nothing big, nothing special. That's typical. Now, when you start getting to the higher voltage, the 460s, okay, you get 460 in between, 460 and 460. Now, if I go from here to ground, all right, I get 120. Same with this, 120, and same with this, 120. Now, I'm not a fan of going from line to ground because sometimes you can lose a phase and it can backfeed through something and falsify your readings. I always go through from line 1 to line 2, or line 2 to 3, and 1 to 3 to confirm my voltage. Some manufacturers do a little thing different. They do what's called a hot leg. Okay, so let me take this out. So what a hot leg would be, you would have 120, 120, and 208. That's a hot leg. Okay. Knowing this, if you put this hot leg on line 2, you can mess things up. So you've got to see if if the system requires a hot leg. If it does, you got to make sure it's wired into the proper. And it's usually the hot leg always goes to L3. Because if you don't wire this right, you can mess every single control up in that system. Okay. So now control wise, this is where we're going to talk about thermostats in commercial versus thermostats in residential. All right. If I have a heat pump, 2 heat, 1 cool, right? We know how to wire that up. Standard. RWYCO/B, common, and G. Nothing different, but a commercial R, Y, C, W1, W2, G. Now we're going still with 2 heat, 2 cool, 2 heat, 1 cool. So when you call for cooling, you're going to energize the Y. Y will also energize your reversing valve. You wire this up as a 2 heat, 1 cool conventional. So like you'd wire this up as a gas furnace. Okay. That being said, yes, I did say that. You wired up as a gas furnace because that is how the controls on these type systems are done. They energize the reversing valve when Y is called and no call for W. When you get a call for W, this will energize your compressor and not the reversing valve. This will energize your heat strips. Okay? So keep that in mind when we're going over these controls here in a minute. This on commercial, if this was a two heat, two cool heat pump, same way. If it was a two heat, one heat, one cool gas, same way. Everything like that is wired conventional. If you do not have an O terminal on your unit on the rooftop, you have to wire the thermostat as a conventional. This is important. If you try to wire it up as this right here, it will not work. Plain and simple. So, from the very first class we talked about with wiring, we know when our thermostat calls for heat, our R, B, depending on the heat pump, Y, G, W, those terminals are energized. So I have a defrost board over here on our board. I got to put on the chair because it is too heavy for that stand. All right. So some people don't like this. It goes through the OCD and they go nuts. Okay. This right here is my coil sensor. I have it marked closed and open. All right. Nordine defrost board. Here's my relay, 99340. If you look right here, this says 24. This one says 24. This one says 120. Here's my two sequencers. Okay. Yes, we have a beautiful Ecobee thermostat. Our transformer, as you can see, it does our 120, 208, and 240. So orange is always 208, 240, red is your 208. And we have a make on break, a delay on break, and a delay on make set relays, which we'll get into that next week on the March 8th. But just for purposes, we're going to power it up. It says hi. And yes, I have it hooked to the Wi-Fi so it can read the temperature and everything else. Now, if you see right here, this green light is lit. That is showing that on this relay, even though I don't have a call for G, my middle two terminals have line voltage. That's why this light is lit up. So you can see I have line voltage. Even when I don't have a call on these terminals, this center terminals are potentially hot and can hurt you. Hence the light. Now this is a 120 volt light. This one down here is a 24 volt light. These over here are 120 volt lights. So right now we are off. We're going to put this in aux heat. And we're going to set it up to 79 degrees. Okay. So what's going to happen is our sequencers, G, indoor fan, heat strips, compressor, outdoor fan. So we're going to get our call. Okay. What's going to happen is it's going to take a minute for our coils in the bottom there, that bimetal disc, to heat up. Once it does, lights and lights will come on. And so will fan. I believe I got the set point set right, so it will allow me to. Of course, there's our 4-day forecast on our thermostat here. I had it set up already, so it should be good. Settings. Yep, we should be good. I have it set for 80. So we're just gonna wait. Let me do this. Go here. Fan on. So there's our fan. You can see our fan is lit. Relay is on. But if you notice right here, this light is dead, right? Because that means I have energized, so there's no more voltage going to this. I could essentially pull this off, lick my fingers, and stick it across there and not get shocked. I would not get hurt. Notice the fan went off, light came back on. I named our thermostat HVAC-Chicks, by the way, too. So, not worried about that. When I tested everything out the other day, it worked, so it takes a minute. I think I got to take the time delay out. Settings. Don't want to reconfigure. Let's go to test equipment. And it did it again. I thought I had my short fixed. Damn it. Well, I guess I get to go do some more relay on this thing and figure out where my short went to again. Wait for this to come back up. Last time I did this, the short was perfectly fine, but let's go to cool. All right, so we're at cool. Set it for 65. So now, if you notice right here, my reversing valve light came on. This is my reversing valve solenoid, which I don't have right here. So anytime you put anything in cool, your reversing valve solenoid is going to be energized. It's going to be energized 24/7 when it's in the cooling mode. Where's it at? This right here. Anytime your thermostat is set for cool, this is always going to be energized. Even when the system is not running, this is energized. Okay. So that's why they're so beefy and they can deal with a lot. Then we have our time delay. Now, I don't have pressure switches wired in here, but I could wire pressure switches in. So once this comes out of our time delay, we'll click our contactor and it'll bring on everything there. So if I were to take something and hit our two test terminals right here, oh, that's a bad fuse. That's not going to do it. We'll take this. I can bypass the 5-minute time delay. It's not reaching. There we go. Had to close the coil sensor. So now we've bypassed our 5-minute time delay. As you can see, we've energized the contactor. Single pole. And throwing power. Now, if you notice, this wire here in the bottom comes off the bottom of my contactor, my line in. It comes over into my defrost board. This is my line out right here that goes over to my outdoor fan. So you have to have your power going through your defrost board. Now I could take that fan and just wire it to the contactor, the line side, and make it come on at that point there. So now as soon as I satisfy this thermostat, I have a delay on my indoor. Contactor's clicked out. But notice, we are still energized our reversing valve solenoid. We know this is still energized because if the fan, let's say the fan motor dies, right? This still doesn't have potential. As soon as this relay stops calling, this will light back up. We'll let it go through that. When I energize in heat mode, this will not be. All right. So relay stopped clicking. Our green light's lit. That's showing we have potential still on these two terminals. But we are not running. Nothing's running. And we still have a call for reversing valve solenoid. So if you walk up to an outdoor unit when it's turned off and you hear something humming, that's this right here. This bad boy is what's making all that lovely noise. Oh, so now this side here goes to my heat strip. So I'm gonna try this one more time. Aux heat, actually. Come on. Let's see here. Nope. Settings. Test equipment. Okay. Let's do heat pump. Stage 1. Pump cool. Now I want heat pump heat stage 1. So as soon as I hit heat pump heat stage 1, our reversing valve light died out. Just gonna wait for the time delay on that there. Hey, Danny, nice of you to join. Let's see if we can get this time delay to kick out again quickly here. There we go. So time delay, heat stage 1, testing. We're not testing the aux heat because I got another short again. I'm not sure where. So let's go back here. Let's go try this aux heat. So we're going to put this just one side on here. And I'll find out which side of these, which basically it's probably this one over here that's not working properly. I should not have a short on that because of the way the wire is. Yes, I know, Danny, you are just, it's killing your OCD. So we got to wait. This one here, it says it heats up 30 to 90 seconds. So hopefully this red light will come on here in a minute. There we go. So now you can see we have our heat strips. They're operational. So now what this one is over here, I don't have it wired in because I think this is a bad sequencer, is when this gets energized, it is bringing on these lights here. Now this one is a heat up 1 to 20 and cool 40 to 110. This one is a cool 1 to 30. So this would kick out quicker than my two little red lights right here. But hopefully I'm gonna put this on and see what happens. Hopefully we don't pop the fuse again. See if it didn't pop the fuse. So I'm not sure if it's in my thermostat or what that's causing this to kick out. So 1 to 20 seconds, you'll see these two lights come on. There we are. So let me kind of hold them down. You can see that the red lights are on. I want to screw this just to give you a little better glimpse. There you go. So as I turn this off, now if I turn this off, this light here, this is 1 to 30, and these are 40 to 110. So watch what happens when I turn this off. 1 to 30, 40 to 10. Yeah, I know they're bright. No, no, that's why I'm unscrew them as thing goes on. But and there you go, boom, done. And still, once again, even though we are not calling for anything, right? System is off. We still have that potential for voltage on this relay. Everything has a potential for voltage. Contactor down here. Even though we are not energized, there's still a potential for voltage on the backside. Because on a 240-volt contactor, this side here, where there's a single pole, has 120 going through it, and it comes back to here. So I went from this side to ground, I'd get 120. If I went across those two terminals, I'd get 240 on the pole. As soon as that contactor is energized, I lose it and goes to 0 volts. Okay, then it's 240 across, not 240 down. Two pole contactor, basically your power's here, nothing's going through. So technically this side would be safe, but depends on how it is. This could have potential voltage as well. Your relays have potential voltage. As you can see, we are lit. Now, this is just basically a heat pump setup, but I've got a little fun here. So I've got, this is where Danny hates it. I've got delay on break. So this timer here, I'm going to try and bring you guys in so you can see this a little bit better. Try to get this foot, there we go. Just slide this over and up. There we go. So as you can see, your break and make timer have these same settings here. And if you look on the bottom, it says cut for 120 volt. Okay. That's the same on the bottom of the other one. You cut this wire if you're making a 120 volt. 30 seconds all the way up to 10 minutes. So you can go 30 seconds or up to 10 minutes on a timer. So you can set this wherever you want and it will delay on that break. So when power is calling in, once it breaks, it will start the timer. With the delay on make, it'll start the timer as soon as a power is energized to it. So delay on break, timer starts once power is no longer being called. Delay on make, timer starts when power is being applied. Okay. So as soon as this loses a call, it starts the timer internally. As soon as the make gets a call, it starts a timer internally. I don't know how well you can see that, but we'll go to this one here. There's your, gives you a little wire schematic on the relay. Okay. So if you're not sure which way it is, it's drawn on the relay for you so you can see how it's set up. Get down here. There's your numbers on your sequencer. Come over here. Not really going to focus but so much, but you can see the numbers on your sequencer. Defrost board. Wires galore for people to have OCD problems. And we'll go over here to our delay on make. As you can see, same timing settings. Cut from 120 to 240. All right. Our little terminal strips that center power everywhere. Transformer, as you can see, my foot caught on that. That would hurt. So, last thing I'm going to talk about. So, we have all seen, like I showed earlier in the beginning, Honeywell T6s. People love these. I am personally profound to the Honeywell Focus Pros. Okay, that and the 8000 was my favorite. Well, again, Honeywell came out with a new Focus Pro, right? And here's what it looks like. It does have battery connections, so you can use batteries if you want. Non-programmable, programmable, everything you can think of, Danny. So I'm gonna try and do this with I don't know how well this is gonna work with this. So I took a picture of all of them. Yeah, the N is none. I didn't get all of them. I took a picture of them all. So I don't know if this is gonna work too well with this here. All right, so I hold it like that. You can see. So we have our settings, right? Now, you see we have our guide here. Well, thank you, Danny. N is non, P is programmable, and S is smart. Yeah, I haven't looked at all of them yet. I just kind of just took a picture of all of them. I was going to run through them when I got a chance to look them up online. But I do like the way they look. So the next is setting 160, outdoor sensor. Okay. 0 for none, 1 for wired. We're going to go 0. Then we have 2000. So we can go conventional forced air, standard 1 heat gas forced air. 2 is high efficiency gas forced air. 3 is oil forced air. 4 is electric forced air. 5 is hot water fan quill. 7 is a heat pump, air to air. 8 geothermal heat pump. 9 radiant heat, hot water radiant heat. And 12 steam. So you can see we can do several different styles with this system. So I'm going to set this for 2 gas forced air efficiency. Next, 210. No, excuse me. Let me go back. I hit the wrong one. Let me get back in the program here. It's still the fan and up arrow to get it there. So next, 160. We already set the 0. 2000 is either 1 conventional force heat, 2 heat pump, 3 radiant, 5 none cool only. We're going to leave that as 1 as conventional forced heat. $210. Here we go. So 210, we're setting it for high efficiency gas furnace. So you can see that's on number 2. So hit next. Our next setting is 270. 270 says heat stages, backup heat stages. Heat stages 1 or 2, backup heat stages 1. So we're going to set this as a 2-stage heat. 271, backup heat stages. So excuse me, I set that for cooling as 270 for 2 stages of cooling, and we're going to set it for 2 stages of heating. So we're going to use a Y1, Y2. 3000, system changeover auto or manual. Now, I like to give my customer the auto ability, so I set it for auto. 315, differential. So the difference between your heating and cooling, I like to set those to 4 degrees. That way you got a good dead zone. So 315, set for 4. All right. 320, finish with high cool stage off. Nah, I'm not too worried about that. 321, finish with high heat. No, it can finish on low stage. 3125, lockout fan after call for cool off. No, we're not too worried about that. We'll leave that off. 31.4, compressor cycle rate 1 to 6. We're leaving it at 3. Heating cycle rate 1 to 12. We're leaving that at 3. Stage 2. Leave that at 3. Then we have what was that, 3240. And guess what? Unfortunately, 3165 is as far as it goes. So we're going to just, that's probably a 5-minute time delay. The next ones are 4000s are your heating and cooling settings. And done. So we have our thermostat. Everything's set up. Now, as you can see, this is our wiring. So we have Y1, Y2, W1, W2, right? So you would wire this up. W for W1, W2 for second stage. If you notice right there on the R section, right here on this side, it says 1 wire or 2 wire. You see how it's pushed up where it says 1 wire? If I were to drop this down and set it for 2 wire, now look, the R and RC terminals are both exposed. So you can use this thermostat for 2 different type systems, one for cooling, one for heating. And if you want to use the U wires, you can drop that down. So you can use UU, and you also have SS. Once you finish it, you can snap it closed. Then all your terminal connections are done. Everything's hidden back here, closed up. You have the choice of, personally, I like the idea of mounting this on the wall, snapping that on, and boom, look at that. That is beautiful. So you can see our thermostat is set for 2 heat, 2 cool. Now, the nice thing about this battery here, and I'm explaining this to you, is I take this, I flip this over. This goes on this side, this goes on this side. If I were to take this and set this to mode, heat, right, and crank this up, my R terminal right here, because the bottom is RC, the next one is R. R, then K, W, E, W2, OBA. So I could go from here to both of my W terminals and check for continuity because I'm battery powered. If I wasn't battery powered, I couldn't check to see if this was actually working with the thermostat off the base plate. I'd have to go back to my air handler and check at the wiring. I could pull it off the wall and skin the wires. Now I have a possibility of us putting a short in the wall and everything else. But I like the fact that we have a battery ability to have this to check this to make sure the thermostat works properly. And that was one of the nice things about the 8000s. You had the batteries, you could check the pins, and same with the old Focus Pros, you could check the pins. The new ones that don't have batteries, batteries are not required. I like the batteries so I can just energize the thermostat and see if I'm getting continuity through my pins to make sure they're working. And when we go over in March 8th about diagnostics, we'll actually do that test. But as you can see, there it is. Thermostats are your brains of the operation. Turn this off. Push that back. Get this back up here. Move things back around. So, normally open, normally closed. All right. All your schematics are wired, de-energized. So whatever it is set for on that, that is what your relay is. This is de-energized. So these top two contacts are always normally open. This is wired, shown de-energized. So this is normally open. Your high pressure switch is shown normally closed because there's no pressure to open the switch. Your low pressure switch, because there's no pressure to close it, is shown normally open. Your fan relays, depending on the style, depends on how it's shown, should be shown normally open on the one of the two terminals. Everything is shown as de-energized. All your relays and controls are done like that. Just keep in member, if power's applied on one side and it's not calling, there is still a possible for potential on the other side. You can get hit. A lot of guys don't realize that. I've got meter leads that I've pushed in to check something and it hit something else and went pow and blew off half my lead. It happens. I've replaced more meter leads than I care to in the first few years of doing troubleshooting and diagnostics. So, any questions so far on what we've gone over? I know some of y'all were late to the party. Basic circuits, understanding the basic circuit of the system. Basically, that's what the board shows you. When we get more to on the 8th, we're going to go over doing testing, troubleshooting, and showing you how to test and troubleshoot that stuff. I'm going to rewire the board with a different thermostat, the Focus Pro, and set it up for gas AC. So we'll use the sequencers as our gas and the contactor for our AC. So it will go through a cycle of gas AC with a different thermostat, which shouldn't be hard for me to change out while we're doing class. I'll have my service bag here and everything with us. Anything else y'all would like me to go over, discuss, please feel free to mention in the comments down below. After this live is over with, if you're not here, if you're watching down the road, I do check the comments and I will be more than happy to make other training videos for what y'all would like. I do enjoy doing this. It's fun. I like giving back. And like I said, some of these trainings will overlap each other because there's knowledge from one to the other that you definitely need to have. So I'm going to give it about 5 minutes or so and open up for conversation and questions. Hope everyone's having a good weekend. I'm not sure if everyone got hit with the snow like we did. Some areas got more. Virginia Beach had a record 12 inches of snow. They haven't had snow in a long time. So, yeah. Just remember, we have live training on Saturdays. Jennifer has training. Let's see here. Let's see here. Saturday, March 1st. So next weekend, Jennifer's doing an A2L training. Then the 8th is the last of our 5-part series for trouble with this low voltage and troubleshooting. Yep, I just looked in the calendar and saw that. It's not on the page though. You might want to get that up on the page. So everyone, enjoy. Have a lovely weekend, and we will. If you, like I said, if there's anything you want training on that I have not covered or Jen hasn't covered, please feel free to comment on our videos through here. Message us on the page, and we'll do what we can to help out and try to get more training for you. Thank you, and have a good one.